All right, welcome back to more labs you can do at home. Today we're going to be researching the science of Oobleck. So Oobleck, which is pretty much a made-up term by Dr. Seuss himself, is just a term for a non-Newtonian fluid. Non-Newtonian fluids are substances that don't exactly know how to behave. Sometimes they behave like a liquid, and sometimes they behave like a solid. So it's not really either one, it's both. So we're going to look at ooze or oobleck. Okay, so what you'll need for this experiment is you will need cornstarch that you can find at your grocery store. Okay,
put it in my bowl.
You will need water. You will need food coloring. It's optional, but it's better colored. You will need a measuring cup. This is a 1 cup. And you will need a spoon, a small object to place in your oobleck to just kind of experiment with it. Either a paper clip, penny, really anything that you have on hand. You will need a mixing bowl, and you will need your hands. Okay, so I have my 2 helpers today, Lorelei, my slime expert, and Landon, my general mess maker expert. So today we are going to make our substance. So the first thing you're going to want to do is you're going to want to measure out 1 cup of cornstarch. So we're going to open this up here. And we're going to measure out 1 cup. You can do more or less depending on what you have at your house. Certainly, I don't want you going and wasting all of your parents' cornstarch. But if you have enough, it does make some fun. Okay, so we're going to measure this out. Actually, I'm going to split it up a little bit, not make full cup on each of those. Just make a little bit today. About a 1/2 cup. Okay, of course you can make more or less depending on what you have. Okay, so now that we have our cornstarch powder into our mixing, now we're going to add a little bit of water, a little bit at a time. No, not food coloring yet. Okay, so we're going to slowly pour a little bit of water and just mixing until we get a nice consistency.
It looks like milk.
It does look like milk. That's a great observation. So as I pour a little bit of water in, you're just going to start mixing it with your hands. That is right. This is a messy lab. So make sure we just start mixing it. If it gets too hard and crumbly, you're going to want to add more water to it. So get your hands in there. You want to get all the powder into the liquid. If it gets too crumbly, that means you need more water. If it gets too oozy, that means you want more solid material, more cornstarch. Okay, so it looks like you need more water in there. Okay, you could probably use some more water as well. So you're going to mix all the liquid and powder together until you get a nice kind of gooey feeling. You don't want it to be too liquidy, but you don't want it to be too crumbly either. So mine is actually a little bit too liquidy, so I need to actually add a little bit more cornstarch. Okay.
Mine is just like water.
All right, so you need a little bit more cornstarch. Landon, how you doing over here, buddy?
Good.
Yeah, keep mixing. Okay, we're going to just keep mixing until we get a nice consistency.
I need more cornstarch.
Oh, you got some over here, so we're going to keep mixing this together.
Yeah.
Once you get it into a nice consistency that you like, not too liquidy, but not too crumbly and dry either, then we're going to add your color. Okay. All right, so we're going to add a little bit more cornstarch here. Whew.
I want to wash my hands. It feels so weird.
It does feel weird. That's what oobleck is. I'll give you just a little bit. All right, mix that up in there. Okay. It's important to go slow when you add water so you avoid the whole having to add a little bit more cornstarch. Okay. Eventually, though, you want to get a substance that you can pick up. Okay. So once you have a substance where you can pick it up and molded. That's kind of what we're looking for.
Make sure you don't eat anything when you're doing the science experiment.
That's also a very good science rule. No eating during science lab. It's the number one rule in my class. All right, so my consistency, I've got a pretty good consistency now. It's not too oozy. I can pick it up and I can start to mold it. So it feels kind of hard, not too liquidy, and not too wet. Okay, let's see how yours is. Yours is still a little bit liquidy. Yours, actually, Landon, yours is pretty good. Maybe could do a little bit more cornstarch in there. Do a little bit more. All right, now that we've got a good consistency, now it's time to add our color. So whatever color you picked out, you're going to open it up. And we're going to put about 3 drops of food coloring into our Oobleck mixture. So as we're doing this, you will notice that all we've done is we've mixed 2 items, cornstarch powder and water. We haven't done any crazy chemistry. We haven't reacted anything.
I want it to drip mine.
All right, make one more drip. I haven't heated anything up. I haven't caused any chemical reactions to occur. That's because Oobleck, or Ooze, is a physical creation. It's a mixture. So all we're doing is we're mixing 2 substances together by physically means. Yours is definitely turning blue. Okay? I put green in mine, just have.
It feels like Oobleck.
It does. Okay? And you can mix this in different ways, but the best way is to get your hands in there. That way you can feel the consistency that you need. All right.
Whoa.
So now you can see that we have a consistency that is not really liquid, but it's not really a solid either. This is what we call a non-Newtonian fluid. It acts as both a solid and a liquid.
And
we're through
actually called a non-Newtonian.
And through our experiments today, we're actually going to see how it acts as both a solid and liquid. So if you're following along at home with the lab that I have sent you, the first thing we're going to do now that we've got our mixture is we're going to gently bang it with a spoon. So Landon, I'm going to take that spoon. I'm going to mix blue. Can I have it? Thank you. Okay, so I'm going to gently bang this with a spoon. So let's see, I'm going to move this down just a little bit so you can see our bowls here. Okay, so I'm going to take mine and I'm going to gently bang it with a spoon. All right, hopefully you can see this at home, but as I gently bang on it with a spoon, it's acting like a solid. It's not going through. In fact, it sounds like it's hitting a solid material. If yours is still acting a little bit like a jelly, you need more cornstarch. Okay? You want to be able to hit it with a spoon, or you can even hit it with your fingers, and you're not going through. In fact, cornstarch and water is a substance where I've seen if you put it into a bathtub or a big container and you jump on it, you won't go through. It's pretty wild. So if you hit it pretty quickly, it acts as a solid. Okay? So now we want to try putting a tiny object on this. So I'm going to take my penny and I'm going to just put it very gently on top of the Oobleck. And it disappears. Okay? But wait a minute. We just banged on it and nothing was going through. Okay? But the penny easily slid through. Now watch this. If I gently put my finger in and go slowly down, you'll notice that the Oobleck moves around and acts like a liquid. So this is what it means by a non-Newtonian fluid. Newtonian fluids are things that Isaac Newton himself described as having certain properties about them to describe them as either a liquid, a solid, or a gas. Things like Oobleck don't act like this. So we call them non-Newtonian. Meaning, it's very good. Meaning it can act as both a solid and a liquid at the same time. So how does that make sense? Okay, so we're going to continue playing with some of our different experiments. So our next one that we're going to do is we're going to take our Oobleck, we're going to transfer it into a different container. So I've got this really cool container here, and I'm just going to take a little bit, if I can grab some, okay, and I'm going to pour or move it into my container. So I'm going to kind of move it here, and as you can see, ooh, it looks like slime. I'm moving it into a container. So as I'm moving it into a different container, it's changing the shape, but the volume or the how much I put into it, that stays the same. Very good, buddy. You can play with it. So this is a property of a liquid. Yes. So this is a property of a liquid. Liquids take the shape of whatever container they're put into. So in this case, it took the shape of this weird round container here. Or if I have it in a bowl, it takes the shape of the bowl. So as you pour it from one container to another, it does change shape like a liquid, but actually can be cut like a solid. So when you cut it, when it's dripping down, it's actually being cut or torn apart like a solid. So again, it has both properties of a solid and a liquid. So the next thing we want to do is we want to squeeze our ooze. Okay, so how are you guys squeezing this ooze? Yeah. All right. So as we squeeze this ooze, what are you guys noticing? I can't even get my ooze.
I like to roll mine in a ball and just watch it like dissolve.
Well, that's actually our next experiment. So as we squeeze it, we're squeezing it and it's oozing through our hands, which is why I call this ooze. Okay.
Yucky.
But now let's try what Lorelei's doing. Let's take our ooze and let's mold it into a ball. Okay. So as we mold it into a ball, does it feel like solid or liquid? It feels like a solid.
I don't know how to do it.
So it feels like a solid ball. All right. But here's the key. In order to keep it a solid ball, you got to keep moving. Because as soon as you release it, yes, I will help you in just a minute. As soon as you release it, it turns into this ooze mess and it starts to flow. Okay. So even though it can mold like a solid, as soon as you open your hands, it flows out like a liquid. Okay. It does not keep its shape at all. Okay. You, buddy, looks like you might need a little bit more cornstarch. Let me get my ooze off my hands here. All right, I'm going to add you just a little bit more. That's actually too much. Hang on. Okay, that's too much. I need to make sure I save some for my class. Okay. Oh, I gave you a lot. Sorry about that. Okay, try mixing that up. All right. So now that we've kind of played around with our experiment, let's talk about the science of this stuff.
It's too wrinkly.
Okay, mix it with your hands. All right. So I'm going to very gently touch my computer and bring you up just a little bit so I'll slouch down so you can see me. Okay. So our ooze, or Oobleck as we are calling it, is a mixture. So what happens is ooze, or Oobleck, is made out of tiny particles of cornstarch, which is a solid, suspended in water. That suspension in water is a special mixture called a colloid. And a colloid is a non-Newtonian fluid. So we call this a mixture because it is physically combined. Because a mixture is physically combined, that means we can also physically separate it. You'll notice you can keep this in a baggie and play with it if you would like to and if your parents are okay with that. But you'll notice after a couple of days, the water will go out and you end up with a hard, crumbly cornstarch material again.
Like that when you
like that. Yes. Okay. That's because the water will eventually evaporate no matter how well sealed you have it, and it will turn back into a cornstarch solid again. Okay. So let's talk about some properties of our Oobleck. Physical properties are anything that you can observe or measure. So some physical properties of our Oobleck, mine is green, okay? Landon's here is blue, okay? And my daughter Lorelei's is purple, okay? So color is a really great physical property of any kind of matter because it identifies what it looks like. Another really good physical property is the state of matter. Now, this one gets a little tricky because Oobleck doesn't really have an official state of matter. Remember, Oobleck is both solid and a liquid. So we could say that a state of matter for this is solid and liquid at the same time, non-Newtonian fluid.
You cannot put Oobleck in the sink, or else you will clog your sink.
It actually can go down your sink because it's just cornstarch and water. It will thin out if you add more water. Okay, so it is safe to dispose down the sink. Okay, another really good physical property is density. Now, if you remember, way early in the year, we talked about density.
Can you give
Density,
my minutes?
Not right now. Density is mass over volume. It tells you how much mass can fit in a certain amount of space. Now, I don't have the tools with me to accurately find out the density of this, but you would need to find out the mass and the volume and do a little division problem. And that would tell you exactly what the density of the substance is. Other physical properties are shape, size, texture, smell, anything like that. Anything that you can observe or measure is physical. Okay? Now, your next question on your lab is, what are some properties that make your ooze act like a solid?
It smells like a farm.
So the only thing that I can say that this acts like a solid is if you bang on it, okay, or hit it really hard, or if you try to mold it into a ball, okay, like I'm doing here.
I can't punch through it.
You can. That's because solids have particles that are really, really close together, okay? So their particles are right on top of each other. They're tightly packed. So when particles of solids are tightly packed, that means you can't get through it, okay? It's not going to allow you to move through it. You can bang on it all you want. You can even walk on it if you have enough of it, okay? But solid particles are so tight that we cannot go through the material. So that's one way that this acts like a solid, okay? However, it also acts like a liquid. It acts like a liquid as soon as you stop moving it or hitting it hard. And it just kind of melts in your hand.
Yeah, it just melts like ice when you leave ice in a warm thing.
Or
Okay.
kind of like our cat right now, who was just walking and then it flopped.
So that's because liquid particles are close together, but they can move around each other. In other words, it flows. Okay? Solids don't flow like that. Liquids do. So this is how Oobleck acts like a liquid. Okay? Another way that Oobleck acts as a liquid is it can change shape, but not volume.
Nope, take her.
Anything that changes shape or takes the shape of a container is a property of a liquid. So it flows, it changes shape, and it kind of has this sinking feeling. So another kind of non-Newtonian fluid that acts very similar to our Oobleck are things like mud, ketchup, and quicksand. Mud is just a mixture of dirt and water, very similar to cornstarch. The dirt particles are suspended in water, and they act as kind of like a substance where you can get stuck in. We've got a creek out back, and we can sink in it a lot. If you hit it hard, you're not going to sink. But if you are slowly moving in, you're going to sink in it, okay? Quicksand, if you guys are ever stuck in quicksand, if you panic and move around a lot, you're actually going to sink further. So the way to get out of it is just very simple, smooth motions, and it acts more like water instead of a solid. So that's ways that Oobleck acts as a solid and a liquid at the same time. Please don't flick it on my computer. Okay? All right. So the last thing we want to talk about with our Oobleck is that these are a physical combination. This is a physical change. Physical just means that it's physically put together. So we didn't actually change what these substances are. It's still water, and it's still cornstarch. Even though this acts as both a solid and a liquid at the same time, this is still just a physical combination of two materials, making it physical. So that is the science of Oobleck. It is a non-Newtonian fluid that acts as both a solid and a liquid at the same time. Join me next time for the science of flubber.
Bye.